Where do we use math in the real world? That is something that teachers hear often. Mathematics is used every day in the field of architecture. Architects design buildings and houses. They do this by referring to what they call floor plans. Now, let's talk to an expert.
Hi, my name's John Lee. I'm an architect. I trained in London and I came up to Manchester to set up an architecture practice here called ARCA, and we've been working here for about 10 years, building all kinds of buildings, art galleries, churches, towers, everything really. So we've had a great time. Favourite subject was probably art. I liked the fact that you didn't quite know what you were going to be doing each week, and that sort of creative exploration that was part of it. When I was at school, I loved maths because of the aspects of it which were that you had an answer at the end of it and you could be sure of the answer. I think that it's difficult always to know how that's going to apply to the real world. We use maths quite a lot, convert meters to square feet and so on, but also there's a lot of geometry in architecture, basic things like getting dimensions right, but also being able to tell builders where to put things, and that involves working out the geometry of a building and being able to set that out accurately. But when you're designing a space like this one, you need to begin by setting out the main parts of it, where the columns are going to go, where the walls are going to go, very basic things, and make sure that everything that the client needs will fit within that. And then from that, you then add more and more detail, working with the likes of structural engineers who nowadays do a lot of calculations themselves. And from that, through getting more and more detail, you then get to a point that you can get a builder to price the work, and then it can begin on site. When I was at school, I learned about all kinds of things, such as trigonometry and calculus and so on. But the thing that I still use really almost on a daily basis is trigonometry. If you're working out a pitched roof, you need to know the slope of that roof, because slates only work at certain slopes, otherwise they leak. So you have to be able to work on trigonometry to check the height of the roof and the width of it, and therefore the slope of the pitch. The best thing I've found about maths is that it tells you that you can solve problems. So when you're in a creative environment and you're doing things which you don't know the answer to, knowing that you've solved things in the past and you know that there is a solution encourages you to explore new ideas. We did a new desk and various other things for Tate Liverpool, and that desk was this very organic shape, we like to call it, sort of almost like something natural, very uneven and flowing and fluid, like a squirt of paint. And so we began by doing a sketch of that, and then we did a computer model, working out the three-dimensional shape. Then we did a physical model using cardboard to test the shape. And then finally somebody made it by hand at full size, and it was over 7 meters long. At various stages along the way, we were describing things either through computer or ourselves using maths.
This is a model that we did for the Tate Liverpool reception desk, and what we had to do is we actually had to make this model virtually, because there was a complicated geometric shape on the front part of it, and to work that out we couldn't do that without the help of a computer, basically. It should show the sort of flowing shape of it, and the idea was that we were trying to create it so that the wheelchair could actually pull up to part of the desk without it feeling like all of a sudden there was a dramatic drop in the shape of the area, really. Front part of this was a very free-flowing shape, so we had to try and model that in 3D to actually try and figure out where geometrically all the curves had to be. There we go. That shows very, very approximately and very, very randomly what the actual form looks like.
Currently designing a major tower for Salford, which is over 40 stories high, and we need to, before we start work on a tower, we need to know the principles of how it might be made to stand up. And so we need to know about proportion and scale, and in order that the thing will actually balance. When we get later on in the process, we will work with a structural engineer to actually engineer it and make sure that the steel is strong enough and that the building won't twist or vibrate at the wrong frequencies. So early on we need to know the principles. Later we have some experts to help us do it. Without maths I wouldn't be able to do what I do. I need to, even with computers and with calculators and whatever, I need to have maths to understand things, particularly to do with geometry, but also to do with the way that buildings are worked out, the fine detail of them.
That is just one example of how math is used in the real world.